I decided to revisit that last problem we had yesterday because we were kind of rushed at the end. As you can tell from the background, I'm not at WSU this morning. I just decided it was a little cold to go out. I have added to the announcement, we're supposed to get up to 7 inches of snow on Sunday. So there will be no in-class attendance either on Monday, Tuesday, or Wednesday of next week. And we'll have it at the regular time, but there just won't be any in-person attendance because we'll either be snowed in or not. I don't know yet. I may be on campus, I may be here. We'll just have to see. Well, let's go ahead and get started. This will be a little different than you're used to. You won't necessarily see me standing in front of the board, although I'll be here. Okay, this is the problem that we started with yesterday. I went back and looked at the video and I found where the mistake that I made was. The mistake I made was when I squared this. Here's what I should have had, x squared plus 8x plus 16, and I had a negative 8x right here. And that was just pure carelessness on my part. I have no other way of calling that. Well, once you put that in here, then the process we used was correct. We distributed the 16. And when you combine all the terms in this, you get x squared plus 24x equals 0. Okay, we're transferring that to the next screen where you're going to have roots of x equals 0 and x equal negative 24. We check those. If we put in the x equals 0 root, we find out that we get an untruth. So we have to discard this value. Now we check the other one, and it does prove to be true. Okay, here's the next problem, which kind of spans over 4. I would have worked this one on the board, but that's not exactly possible in this environment right now. Okay, you have the problem. I'm going to square both sides. Since this one is isolated, that will completely eliminate that radical when I square both sides. And I get 3n minus plus 1 there. And over here, I have to FOIL this 1 plus n plus 4 radical, which gives me 1 plus 2 times the middle term, 2 times the first times the second term, plus the last term squared, which is n plus 4. Now I move this over to the right. I move this over to the right. Okay, and here's the 1 and the 4 that I both moved over, which gives me this value, 2 times radical n plus 4 equals 2n minus 4. So I divide both sides by 2, getting n plus 4 equals n minus 2. Now I have to square this thing a second time to get rid of this radical. And I have to square and FOIL this, which comes up here. This becomes n plus 4. When you square this, it becomes n squared minus 4n plus 4. Okay, so I move this over to the right, move this over to the right by adding their opposites, and I get 0 equals n squared minus 5n. I factor that, excuse me, and I get n times n minus 5, giving me values of 0 and positive 5. Now, right now, I don't know if both of those are okay, so I had to do a check on both of them. So in this case, I did a check with n equals 0, replacing the 0 in both places, and I see that I get 3 equals 1, so that's not a truth. So we have to discard the 0. We do the check on the 5 in a similar manner, and we see that it does prove to be true, okay? Because we get a 4 equals 4. So my solution set then is the set containing the value 5. Now we're going to take something new. These are called rational exponents, meaning fractional exponents. And basically the way you get rid of them is doing the opposite. In other words, multiplying both sides by the reciprocal of the fraction. Now you can do that in 2 steps or you can do it in 1 step. In this case, I'm going to take the reciprocal of 2/3, which is 3/2, and I'm going to multiply it by both sides. And because I have a square root, the 1/2 power is a square root, I have to do the plus or minus. Okay, here. Now, this 4 to the 3/2 power, the numerator is the power of the base. The denominator is the root. So 4 to the 3rd is 64, plus or minus that's a strange looking minus sign there. So the square root of this is plus or minus 8. And it does check. Now, here's an alternative way of working this problem. I said you could do it in 1 step, like we did here, or you can do it in 2 steps. In this case, we're multiplying each side by the power of the denominator of the fractional power. Well, 2/3 times 3 is just 2. And here, 4 to the 3rd is 64. Now, it didn't show it, but I took the square root of this, and I took the square root of 64 plus or minus, resulting in the same plus or minus 8 answer. Okay, 1/5. I can take both sides to the 5th power. It's not a problem, even though this means the 5th root of this thing. It's not a problem, this being a negative, because 5 is an odd number, an odd root. Now, if that were an even root, then we would have a problem and be no solution if it were, for example, a 2 there. Okay, so we're going to take both sides to the 5th power. That gives us x plus 1 here. -3 to the 5th power. We have 3, 9, 27, 81, 243, and 5 powers of negatives is negative. We subtract 1 on both sides, and we get -244. And this solution does check. Two times x minus 4 to the 3/4 power equals 54. First thing I would do is I would get rid of this 2 out front, That 2 is not impacted by this 3/4 power because it only applies to the parentheses. So I divide both sides by 2, and I get the x minus 4 to the 3/4 power equals 27. Now, I just left this left side alone. 27 happens to be 3 to the 3rd, 3, 9, 27. Now, I probably should have multiplied both sides to a 4th power, but I didn't want to deal with large numbers. So I decided to take both sides to the 3rd power first. Okay, so in this case, the 3 and the 1/3 cancel out, leaving me a 1/4 power. The 3 and the 1/3 cancel out, leaving me a 3 to the 1st power. Okay, now this, to get rid of this 1/4 power, I multiply both sides by a 4th power, leaving me the parentheses, and 3 to the 4th is 81, 3, 9, 27, 81. I add 4 to both sides, and I get the solution of 85. Okay. Let's go into a couple more problems. There will be a problem like this one on your worksheet that's due. First, let's just look at this as square minus 3 to the 1st power minus 4. Notice this power is twice as big as this hidden 1st power. Over here, this power is twice as big as this 2nd power. That's a consistency that'll allow you to work this the way I did the 3rd time. We're going to work this problem once and these two as well. Okay, you factor this, x minus 4, x plus 1 equals 0. Gives you the two equations using the zero products rule, and we have x equals 4. And x equals -1. Now let's go to this one. We're going to do this by what they call the substitution method. We're going to let the letter u, arbitrarily chosen, stand for x squared. Well, how many x squares are in this? 2 of them, okay? Because x to the 4th is x squared times x squared. So if u is one of these, this to the 2nd would be that to the 4th. Likewise, we're replacing this x squared with a u here. Now we're going to factor this. Well, it factors just like we did here. And I get those two products, except I'm not done yet. And you notice this produces the same values here. I'm not done yet because now I've got to go in and replace this u right here with an x squared and replace, and I'll go ahead and solve that. Square root of this, square root of that, plus or minus, and I get plus or minus 2 for my answer. Over here, replace the u with x squared. Uh-oh, we're going to get an imaginary number. So we get x equal plus or minus I. In this case, we have 1, 2, 3, 4 answers to go with a 4th degree equation. Over here, we had 1, 2, 1, 2 answers for a 2nd degree equation. Now I want to show you a slight variation instead of using this substitution method. Because this is twice as big as that, it can be factored in a similar manner. So I just brought this whole thing down at once. I can factor this thing into x squared minus 4 and x squared plus 4. See how that correlates to this, except I've got squares instead of just first powers because of that being x squared squared. Okay, this in turn is a conjugate pair that can factor further, giving me 2 and negative 2. This one cannot be factored because of that plus in there. So I have to use the property of square roots to take the square root of both sides, plus or minus, and I get x equals plus or minus 1i, just as I did over here. Now, I don't know which way you like better. Most of the time, I prefer it this way for myself, but sometimes it depends on the problem. You may want to do it by substitution. Now, here is a fractional problem that we can also factor using substitution. The substitution we're going to do is we're going to let u equal x to the 1/3 power. Okay? Well, then if u is x to the 1/3, then we've got u to the second. And here we've got u to the hidden first. We factor that. And by the way, if you notice, these are the same numbers that we had on the last problem. So we should get similar factoring. It's just so you can see the consistency. So here we got the 4 and the -1, just like we did on the previous 3 problems. Except we've got to go ahead and do our substitution now. So we replace this with the x to the 1/3. How do we get rid of this 1/3? Take both sides to the 3rd power. Giving us 64 and -1. Okay. And that would be our solution. And these do check, by the way. So if we do the substitution, you put it in there, you factor, you get solutions, you substitute, multiply out, and finish solving it. Okay, this one we're going to save for Monday. This is where we're going to start on Monday. This -2 power means that this is 1/2x quantity squared, but we'll deal with that one on Monday. Okay, now we're back. I almost canceled our meeting by accident then. Now, I told you that we would spend part of today going over the answers to the problems on the handout sheet. So we're going to do that now. And here they are. Now, as I told you before, you are welcome to write down the correct answers. Okay, and then if you had an incorrect answer, I'm going to allow you to go ahead and rework this problem, showing your work, so that you do get a correct answer. Now, if you get a correct answer showing the work, not just because you wrote down my answer, then you get to give yourself credit for it. There are going to be 40 gradables. I have a few of these problems, for example, 3 through 7, that you did not have to do from the list on the assignment list. But at any rate, what you need to do is subtract how many of these, after you do your corrections, how many of them that you missed from 40, and put that on the top of your worksheets that you submit to me through Blackboard. And those have to be in by 10 o'clock tonight. Okay, here we go. Given this trinomial, if C is positive, then both are positive. Given a trinomial, if C is negative, then one is positive and one is negative, or they are opposite signs. Question E, in a perfect square trinomial, positive, positive, factors such as A plus B, quantity squared. Likewise, in this one where you have a negative here and a positive there, A minus B, quantity squared. Okay, I'll go ahead and do number 3 in case any of you did it. 6c squared d fourth e seventh times the quantity 6d cubed e fourth plus 2c d e to the 8th minus 1. And it's real easy to forget that 1 out here on the end, because this went into all of that one time. Number 5, 5x squared y squared times quantity xy plus 3x squared minus 7y squared. Or you can reorder what's in the parentheses from x's to y's. This is actually the preferred answer. Number 5, 3a minus b and 2x minus 1. This is called factoring by grouping. We did one problem on this style. You have a constant term or constant here. You pull these out, leaving the 2x minus 1 that's hidden in front of this before you factored that out. Number 6, 3 times y minus 8 times 2 minus u. Number 7, quantity 8 plus 2 times quantity wz minus 33a. Number 9, b minus 4 times b minus 8. That's just standard factoring. Number 10, x minus 9 times x minus 3. Number 12, w plus 9 times w minus 6. Number 15, c minus 8 times c plus 2. Number 17, x minus 5, 2x plus 3. Number 19, a plus 1 times 6a minus 5. That one's a little more challenging. Now, first step you had to do on this one is you had to change the order and put the 6a squared first. Likewise, this one you can leave in this order from S to T, or you could switch it from T to S. Here you get S plus 3t and S minus 2t. Number 22, p minus 5q, p plus 4q. Number 29 is prime. It will not, it will not factor. I think I'm getting the hiccups, I hope not. Number 40 is also prime. Number 43, 2a plus 3, 7a minus 4. Number 46, 3c is a common term you can take out of everything. And then you can factor it into 2d plus 7 and d minus z. 47a. We FOIL these and we get x squared plus 10x plus 25. Or you could use first term squared plus 2 times first times last plus last term squared. Either way. That rule A. Question B. Now they're asking you to factor this answer, which goes back to what it started. 48 is kind of the same sort of a thing. You have to multiply these. You get that. Then it asks you to factor that, and you go back to what you started. Number 49. You FOIL these. You get 9x squared minus 12xy plus 4y squared. You factor that. Once again, you get the 3x minus 2y quantity squared. Number 51, 30x is the number that makes this thing a perfect square, because you got a 3x and a 5 on each end. And 2 times 3 times 5 is 30. Okay, number 55. This factors into y minus 4 quantity squared. Number 56. That happens to be a perfect square with a 1x on the front and a 5 squared on the back, so x plus 5 quantity squared. Perfect square on the front, 8m squared, and 5 squared, and that gives us 2 times 8 is 16 times 5 is 80, so the middle term checks, so it's 8m plus 5 quantity squared. Number 58. 10c minus 7 quantity squared. Again, perfect square on the back, perfect square on the front, and we test the middle. Number 65, you can factor a 5 out of all 3 terms. Then you got b squared minus 2 quantity squared. Okay. Number 67a, u minus 5 quantity squared. Here you notice they've got the same numbers, just double the powers. So you've got x squared minus 5 quantity squared. Now, technically, you should go ahead and complete working this one, but I will accept this answer. Now, you can get an answer of x equals plus or minus 5i, or square root of 5i. Plus or minus square root of, no, plus or minus square root of 5. Okay, number 69, here we factor that. Notice this power is 3 times that, this power is 3 times that. So we use the substitution of a equals w to the third, or w to the third. Anyway, you factor this, you get these 2 terms. Technically, you should go ahead and work each one of these individually and bring them down, but mainly I was just wanting to know if you could do that first factoring. So I'm content with these answers for now. Okay, number 80. Again, we have an elevated power. This one is twice as much as that one. So it breaks down into t squared plus 2, t squared plus 1. And I don't think that a PDF will let me write on it, but this, no, it won't. Okay. So this would be, where are we? Here we go. This one would break down into t equals plus or minus square root of 2i. This one would be t equals plus or minus I. Number 83. Okay, what's wrong with this? This is what it's asking. Why did the professor deduct several points, even though this is true? It's because this can still be factored a 2 out of both of these right here on this term. So we factor a 2 out of these two, which leaves y minus 2 right here, y minus 2. And this one remains the same. Here would be the complete factorization. They would have been better off factoring this 2 out at the very beginning right up here. Okay. Number 87. A perfect square on the front, perfect square on the back. Both of them are pluses. We can test the middle. 9 times 2 is 18 times 5 is 90. So 9w plus 5 quantity squared. Perfect square on the front, perfect square on the back. A minus here. So both would be minuses, and it factors in the 7a minus 2b quantity squared. Number 90. I've got a t minus 8 and a t minus 8 that I can factor out of this whole thing. So I've got this t minus 8 that I factored out. Well, first of all, I can factor a 2 out of both of these. So I did that. And then I've got the t minus 8 I factored out, leaving a 2p, because I factored the 2 out of this first term, plus 1, because I factored the 2 out of that term. Number 92. As I look at this thing, 6xz will go out of all three of these terms. So I pull it out, and here's the remainder, and there's nothing we can do with that. Number 95 is prime. We could solve it by the quadratic formula, but it doesn't ask us to do this. This is strictly a factoring handout. Okay, number 99. Now, on this problem, had you chosen to, you could have made this 3d squared minus 4d plus 1 in that order, in which case you would have had this answer, 3d minus 1, d minus 1. Or in the order that it's in, you would have 1 minus 3d and 1 minus d. And those are equivalent answers. Problem number 100. Once again, I could reorder this in descending order and get this answer, or I can put it in ascending order and get this answer. Notice the order of the signs. Here I have a positive 1, a negative 2a. Here I have a negative 1, a positive 2a. Here I have a negative a, positive 2, positive a, negative 2. Those offset each other. These are equivalent answers. Only difference here, we haven't really discussed yet set function notation in number 106, 107, but basically you still factor them the same way, and we'll deal with that a little bit later. This value factors into 2x minus 1x plus 7. This one factors into x plus 4, 3x plus 2. And on problem number 8, 108, again, just the factoring portion of this thing gives you t minus 11 quantity squared. Okay. Okay, I hope all of you were pretty successful doing this sheet. If you have any questions right now, feel free to unmute yourself, turn on your video if you wish, and we can, I see that I've got Diners and Dives on the TV behind me. Anyway, that's one of my favorite shows. A hobby of mine is cooking, as well as several other hobbies. Hopefully you'll get all of this scanned in or taken pictures with your phones and convert it to a PDF and get it to me by 10 o'clock tonight. And then over the weekend, I'll try to get the grades posted on them. Now, a word about grades. I know there's a grade book in Blackboard. I don't use it. It'll show up because I've got them linked. But the grades that'll show up for you in Blackboard are the unweighted grades. So your true grade, if you want to see what you're doing, is when you have Alex open, then go into the grade book in Alex, and then you can see what your true grade actually is. And in fact, after the final is graded and posted in Alex, you'll be able to go to Alex and look at it and see what your overall grade is and predict how you were able to do. We'll talk about that more in the future. Now, if any of you have questions, now is your chance. If you don't have questions, then we're going to take off a little bit early today. I'm sure that doesn't terribly disappoint any of you. Okay.